Yes guys, I'm Alex.
I'm Aaron.
And this is Newscast 2022. Now, we're going to be talking about 6 different things today and I hope you enjoy them all. Right, so the first thing is, listen to this. Usually electric cars take a while to charge, but with new self-charging lithium batteries, it will take 11 minutes for you to charge your car. Now imagine, you've driven 5 hours, you're now in Bournemouth, and you need to charge your cars. You can't wait in Bournemouth for 2.5 hours. You go to Costa, 10 minutes, you're done. Your car's charged, you can go again. Next thing you know, you're in the Lake District.
On to some space talk. A pair of black holes have been spotted wobbling at 3 times per second as they merge together. This is an example of Einstein's theory of relativity, which states that space-time does matter how to curve, and matter tells space-time how to move. This wobbling is like a spinning top when it starts to slow down, and it's called a precession, and it's when the rotation of the black holes rotates over time. So why is this interesting? This has never been seen before at this level, and it's only been seen in neutron stars, but was so small at like a rate of a few times per year. This is 10 billion times faster than before. This merging is new and crazy occurrence, and it shows that space and time are really warped in crazy ways. To identify this, scientists used gravitational wave detectors, which produce sources of noise and confirmed the precession was occurring. None of this was expected to happen, so this revelation was astonishing to the science community.
Now, we all know physics can't be physics without a bit of quantum entanglement. Now, recently in a lab, the first ever quantum engine was trialed using quantum entangled bits. Now, what this means is, instead of being powered by traditional energy, this quantum engine is powered by measurements. Because in a quantum entangled bit, if you measure a bit that's over here, you know the state of the bit that's over here, and that releases energy.
Had the quantum batteries yet? Well, there's more. All you ever hear about is climate change and CO2 emissions reaching new levels, while quantum batteries are being made which can provide instant power to cars, and this will stop you waiting for hours on end while your electric car charges. Isn't that crazy? Almost 3/4 of the greenhouse gas emissions come from transport, so we urgently need to reduce this, or else we'll be doomed. Quantum physics may save us. By leveraging the behavior of subatomic particles, a quantum battery could charge itself faster than any other device. This means that future dead batteries could resurrect themselves, like that. See, you may say lithium-ion batteries already exist, but they stick to the positive electrode, and if charged too quickly, they could cause a massive explosion, which is not wanted. In a quantum battery, stuff that exists in low energy states, which can basically chill in high energy states until it's needed. This stuff is made up of qubits, and the qubits must have an inextricable link between them so energy can be extracted. This doesn't increase the energy output, this will increase how fast the battery can be charged. And if you entangle more qubits, the route to full charge gets reduced and a faster path is made. So who cares? This allows us to drive through charging stations, and this means stopping your car won't become an issue in the future.
Now, away from all of this, let's put a little bit of a lighter spin on things. Did you know that you at home could make an electric motor using just a battery, a wire, a magnet and a flathead screw? All you have to do is attach the flathead of the screw to the top of a little magnet, and then touch the tip of the screw to the bottom of a battery, and then use the copper wire and attach the copper wire to the bottom of the magnet and the top of the battery, and the screw should spin. The reason this happens is because of the wire connected to the battery and the magnet, it creates an electromagnetic force which should cause the screw to spin around itself. And I think that's magnificent, don't you?
Yeah. Well, on final news, yesterday it was found that physicists made the most precise measurement of a single particle ever. This is crazy because it tells us about new physics happening at the tiniest of scales. The measurement was 1.3 parts in 10 trillion, which is incredibly small, and 2.2 times more precise than the last measurement. They did this by trapping an electron in a chamber with a mega stable magnetic and electric field at a temperature of just above absolute zero. For those who don't know, absolute zero is minus 273 degrees. And then they measured the response of the electron as the magnetic field changed. With this precise measurement, they should be able to compare the electronic magnetic moment value with a standard model and see if there is any difference. And if so, a new model for the electron will have to be made. Isn't that crazy?
Yeah. So thank you very much guys for listening, and we'll see you next time.
Peace.